Hi, welcome. This is Regina. In this video, I want to talk about naming ionic compounds. First of all, let's understand that an ionic compound is made up of cations and anions. Remember that cation is formed by metals losing an electron. So there is one exception to the cation, which is ammonium. Ammonium is not a metal, but it behaves like a metal cation. The second part of the same compound is anion, which has a negative charge. I want to put a minus here to remind you that anion has a negative charge and a plus for cations, which is usually a positive charge. And again, the cation, the positive, is always written first, anion written second. To name the ionic compound, we simply name the name of the metal or ammonium if it is ammonium. The naming of the anion is a little tricky. I want to divide it into two parts. One, if the anion is a simple element, which is usually found in the periodic table, the name ends in an "ide." So if a metal cation like potassium, it combines with the anion oxygen, we simply say potassium oxide or potassium chloride or potassium iodide. But if it's a polyatomic ion, which is basically made up of several atoms clumped together and carrying a negative charge, then there are two ways of naming them. You could make a short list and memorize them. And I will talk about the short list in a minute. But then I have a nice little trick which can help you figure out the names all on your own. So let's move forward to the next page, and here's the short list of anions which I'd like you to memorize. Pause the video and write this down. OH 1- is called hydroxide. C2H32 1- is called acetate. CN 1- is called cyanide. Cr2O72- is called dichromate. CrO4 2- is called chromate. MnO4 1- is called permanganate. Notice that these are also metals, but they will not be considered cations. They are part of the negative anion. I now want to talk about Regina's trick for the rest of the anions. Pay attention to this, pause the video and copy this down. Understand that this is carbon, nitrogen, and halogens. And halogens are fluorine, chlorine, bromine, and iodine. This is phosphorus and this is sulfur. This is O subscript 3, O for oxygen. Subscript 3 means 3 atoms of oxygen, or 3 moles of oxygen rather. And this is 4 moles of oxygen. Remember to write 4 as a subscript. These numbers in red are the charges. 2-, 1-, 3-, and 2-. I will show you how to put them together to create a polyatomic anion. Let's take carbon for example. Write carbon, bring the O subscript 3 down to the right side of carbon and bring the charge as a superscript, and you have created carbonate. Okay. Similarly, you can bring a halogen. Let's bring bromine. Bromine will combine with O3 and it will have a 1- charge, and this is bromate. Well, it turns out that each one of these will make something and they will always end in an 8. Let's call this rule the 8 rule. Shall we? Okay, so here I have this whole 8 rule reproduced here. And remember 2132. It's easy to remember. Just remember 2132. Carbon, nitrogen and halogens, phosphorus, sulfur, O3, O4. How would I make carbonate? I just did that. Put C for carbon, bring in the O3, superscript 2 minus, and that is carbonate. Let's do sulfate. Bring in the sulfur, and it is lined up with O4, so O4, and it is 2 minus. How about phosphate? Phosphate will combine with O4, so PO4, and it is 3 minus. So you can see you can make all of these polyatomic anions, and the only thing you really need to memorize is 2132. And if you looked at your periodic table, you'll see that the carbon, nitrogen, phosphorus, and sulfur are arranged pretty much in the order that I've written on the board. Of course, you have to remember to bring in halogen with the nitrogen. O3, O4, smaller number on the top, larger number at the bottom, O3, O4, 2, 1, 3, 2. Let's make nitrate. NO3, and 1 minus. Let's make chlorate. Chlorine is Cl, so Cl, it's O3, 1 minus. Fluorate. Fluorine is F. Put a little colon here to separate them. Fluorine is F, and it will combine with O3. It's 1 minus. You can make bromate. Symbol for bromine is Br, and your 2132 rule or your 8 rule tells you that it will combine with O3 and it'll carry a 1 minus charge. Iodate, I-O3, and it'll carry a 1 minus charge. Chlorine, bromine, iodine, fluorine, they were all halogens. The rule doesn't stop there. If you dropped 1 oxygen from the 8s, you turn into ites. If you dropped 2 oxygen from the 8s, you will make hypoite. For example, if you had ClO3 minus as chlorate, if you dropped an oxygen and turned it into ClO2 1 minus, it became chlorite. If you dropped 2 oxygen, let me change my color here. If you dropped 2 oxygen from the 8, if you ended up with ClO 1 minus, 3 minus 2 is 1, it will become hypochlorite. If you added an oxygen, it will become perate. For example, if you had Cl from the 8s, if you add 1, it becomes 4, it becomes perchlorate. So I'm just going to put chlor here. It will become perchlorate. If you added a hydrogen in front, you have to drop a charge. So if you have sulfate, and if you added a hydrogen in front to make it hydrogen sulfate, remember to drop a charge, 1 charge for each hydrogen added. Let's practice what we've learned. Let's practice naming this. So first of all, we have to bring in our 2132 rule. It's 2 minus, 1 minus, and remember this was carbon, and this was nitrogen and halogens. I'll just put HAL. And then there's phosphorus and sulfur. If you forgot the carbon, nitrogen, phosphorus, sulfur, it's arranged in this order in the periodic table. Halogen is the one you have to remember. 2, 1, 3 minus, and 2 minus. I usually remember it as 21, 32. So the top guys will combine with O3, and the bottom one will combine with O4. Okay, so sulfate is going to be SO4 2 minus. So SO4 2 minus is sulfate. SO3 2 minus, we just learned that if we dropped one oxygen from the 8, it becomes an ite. So sulfate, dropping one oxygen, this must be sulfite. Okay, I added a hydrogen, which meant I had to drop a charge, and this becomes hydrogen sulfate. C carbonate, O3 2 minus, there's no oxygen dropped from my 8 rule, so this will be carbonate. I dropped an oxygen, this would be carbonite. From the 8, I added a hydrogen and dropped a charge. This becomes hydrogen carbonate. Moving on, naming some more anions. And again, I will write down my rule here, which is carbon, nitrogen, and halogen, phosphorus, sulfur, O3, O4, 2 minus, 1 minus, 3 minus, 2 minus. Just a little note here to remind me, it's chlorine, it's halogen. To make chlorate, I will need ClO3 1 minus. In fact, I see a chlorate here, so I will put down chlorate right next to this. Always start with 8s, even if they're not asking for it. Dropping one oxygen gives me chlorite. Dropping 2 oxygen gives me hypochlorite. Adding an oxygen gives me perchlorate. How about PO4 3 minus? It's phosphorus, and it's coming straight out of my 8 rule. I'm not dropping any oxygen or adding any oxygen, so this would be phosphate. And here I dropped an oxygen, so this would be phosphite. I go back to phosphate. I added a hydrogen in front and I dropped a charge. So this one would be hydrogen phosphate. Here I've dropped 2 charges because I had to add 2 hydrogen, and di in chemistry means 2, so it is dihydrogen phosphate. All right, let's go ahead and name ionic compounds now. So we learned to identify the first element, which is a metal, and in this case it is lithium. So I shall write down lithium. And the second one is an element, so it's will end in an ide, so it's iodide. Let's try the second one. The first element is sodium, so I will identify that as sodium. The second one is SO4, so if I were to go to my 8 rule to see if it indeed is an 8, if it's not, then I may have to drop an oxygen. So remember, we have O3, O4, and this is carbon, nitrogen or halogen. Then you have your phosphorus here and sulfur is right here. And it's 2, 1 minus, phosphate is 3 minus, and sulfur is 2 minus. So SO4, 2 minus, is sulfate. So I will make this one sodium sulfate. All right, for this one here, the first element is potassium. The second one, I don't think my trick's going to help me here. So we may have to go to our list that we need to memorize. And it's this one here, it's acetate. So I would name this as potassium acetate. Remember, we talked about the first element, ammonium, which is an exception to the rule. It's not a metal, it is polyatomic, but it's the only cation that is polyatomic. So this one is ammonium, and we'll think about the anion in a minute. Now the second one, let's see if our 2132 rule can help us, or the 8 rule. Nitrogen does combine with oxygen, and it may have a 1 minus charge. It's nitrate, NO3. So it is indeed nitrate. Once the cations and anions have combined, the charges are neutralized. So you never want to write the charge after they've combined. This one, it's halogen. So it will be ClO3 1 minus, it's chlorate. And the first element is potassium, so I will name this as potassium chlorate. Okay, your periodic table will tell you that the first metal here is cobalt. And because it's a transition metal, you must always say the charge in Roman numbers. So go back and see what charge SO4 will carry, and you can tell SO4 will carry 2 minus charge. So that's the charge you're going to put here. And the name of SO4 is sulfate. It comes straight out of your 8 rule. Okay, practicing some more. First element is sodium. Let's see what ClO4 is. So if you have your carbon, nitrogen, halogen is right over here. And you know that it'll combine with O3. And of course, this would be phosphorus and this would be sulfur. It's 2 minus, 1 minus, 3 minus, 2 minus, and this is O4. So our rule for adding an oxygen was per 8. So we will name the anion as sodium per chlorate. Next one is barium. Your periodic table will tell you that that is barium. You don't have to memorize that one. Now in looking at the anion, it doesn't look like my 2132 rule or the 8 rule is going to help me. Let me check into my memory list. And OH is called hydroxide, and of course the charge will disappear because it has made an ionic compound, so this would be barium hydroxide, because the anion that made barium hydroxide was hydroxide. It is important to understand the charge though. And I would say this is iron. Iron is a transition metal. You must put the subscript over here as the charge of the iron. So it will be iron 3 hydroxide. This is barium again. Now look at the second anion here. It's an element, so it'll end in an ide. It's simply fluoride. This is tin. It's a transition metal. Whenever it's a transition metal, you put the subscript that you see on the anion in Roman numbers right next to the metal. Element 2132 or my 8 rule or Regina's trick is not going to help. It's not in our list of anions that we memorize. It's a single element, so we simply say oxide. This is a metal. It's lead. And if we went to our tiny little rule, I'm going to write it down here: carbon, nitrogen, or halogen. This is 2 minus, 1 minus, phosphorus is here, 3 minus, sulfur is here, 2 minus, and the top one is O3 and the bottom one is O4. I want to check if I can make SO4. Indeed I can. It's SO4 2 minus, but the negative charges will disappear. So this is simply sulfate. Now if I had another one which was PbSO3, I would say to myself, well, sulfate is SO4, but the question is asking for SO3, then I would label this as lead sulfite. So it's still important to make the 8s and then compare the number of oxygen. If it's 1 less, it's ite. If it's 2 less, it's hypoite. Okay, moving on. Let's go backwards now. If you're given the name like this, the best thing to do is to write the symbol of the metal, and the Roman number gives you the charge. Now go ahead, you notice that it ends in an 8, so you'll use your rule: carbon, nitrogen or halogen, phosphorus, sulfur, O3, O4, 2 minus, 1 minus, 3 minus, 2 minus. You want chlorate, so it'll be in the halogen. So it'll be ClO3, 1 minus. So that's how you figure out ClO3, 1 minus. Then what you do is you take the absolute value of this number and put it right here, and you take the absolute value of this number and put it right here. So your formula will be Cu1, and you don't have to write a 1. Tuck the polyatomic ion in the parentheses, ClO3, and then put the 2 on the outside. So that's copper chlorate. And to name it, just like we were doing before, you're going to identify this as copper. You're going to put this 2 back here, and then you're going to go up here into your 2132 rule and then determine whether this is a chlorate, chlorite, perchlorate, or hypochlorite. Let's try naming lead chromate. Lead, let's try to find the formula for lead. First, what you will do is write the symbol for lead. Your periodic table will tell you that it is Pb. Roman 2 tells you it's 2+. You look at chromate. You know it's not going to be in the tricky rule we just learned, nor is it a pure element, so you will have to go to your memory list and memorize it. So chromate is CrO42-. So that's what we will write down. CrO42-. So if you did the absolute value of 2, you'll end up with 2 here and 2 here. They actually cancel out. So for every, you can see it's 2 positives and 2 negatives, and you really only need 1 formula unit of lead and 1 formula unit of chromate to make this ionic compound right here. Okay, you notice there is no Roman number here. Calcium is an alkali earth metal. It's group 2. They will automatically have a 2+ charge. It ends in an "ide", so you know that the symbol is in the periodic table. Kind of work backwards now. So it's F. All halogens are F1-. So when you combine them, you can see you'll need 2 F's to balance the 2+ in the calcium. So it's calcium F2. And if you did this, what we call crisscross, you'll end up with the 2 on the outside. I didn't put parentheses with F because it's an element, it's not a polyatomic ion, and I don't have to tuck anything in the parentheses. Let's create the formula for lithium hydrogen sulfite. Okay, underline the first metal only. Look up the symbol in your periodic table. It's in group 1. So group 1 again will automatically be +1. The rest of it is the anion. We can use our rule here. So sulfur, this is what we want. Let's create sulfate. You always start from the 8. So it's SO4 2-. From the sulfate, drop 1 oxygen and you get SO3 2-. And remember, when we drop an oxygen, it's an ite. So we made the sulfite. Then what we need to do is turn that into hydrogen sulfide. Add a hydrogen in front and drop a charge. There. That's the guy we put next to lithium. HSO3 1-. Now let's go ahead and crisscross it. So 1 lithium. I will tuck this in the parentheses even though it's not necessary because there's only 1, just to show you that it is a very large polyatomic ion. There should be a 1 here. Let's try another. Copper is Cu. I already know it's 1+, I'm told that. Chlorate. Let's go back to my rule here. Chlorate, you chlorate, so it's an 8, so we don't have to drop any oxygen, so it'll simply be ClO3 1-. And the formula would be CuCl ClO3, and let's tuck this in a parenthesis even though it's not really necessary in this one. One more. How about potassium hydrogen sulfate? Okay, so let's go ahead and put down K for potassium. Look it up in your periodic table. You will see it's in group 1 and it's a positive. Let's make sulfate. Sulfate would be SO4 2 minus. Hydrogen sulfate, add a hydrogen in the front and drop a charge. Keep the number of oxygens. So that's what you'll have here is HSO4 1 minus. Crisscross, you get a 1 here and a 1 here, so your formula would be KHSO4. And at this time I will not put a parenthesis. It's really not necessary because there's only a 1. So I will stop right here. Thank you very much. I'll see you again. Goodbye.